Hi everybody. Today we're going to talk about big data in the science classroom. So first off, you're probably asking yourself, what is big data? So data, as you expect, deals with large amounts of data, but it also encompasses a little bit more than that, including devices that collect data, um, digitally digitizing traditional data, and also machine learning or artificial intelligence. Okay, so the important thing about big data for us is that it has a wide application and it is certainly a 21st century skill. So it's something that our students are going to um, need in the workforce. So how can we bring it into the science classroom? Why is it relevant to us? So technological improvements in data collection and storage over the last few decades have led to a change in the way science is done. So we don't really see the individual scientists collecting a lot of data and then presenting that data at a conference individually as much anymore. Much more frequently, we see large teams of scientists working with large amounts of data, such something like CERN, um, and that's sort of how science is done more. So we can see that big data is playing an integral role in modern science, and we shouldn't expect that to change. So if we're going to build the next generation of scientists or just scientifically literate students, we want them to be able to deal with big data. In addition to that, it also touches on our NGSS practice of analyzing and interpreting data. Okay, to get to the next step there, all we need to do is start integrating big data into what we already do with that in relation to that practice. So how does big data fit into the science classroom? There's a number of resources that we can use to collect big data and get it into our classroom, okay, including smartphone, um, sensors, satellites, gene sequencing. All that stuff is collected as large sets of data that students can analyze. Many government organizations have their data sets available, such as NASA. And analysis tools such as Google Sheets can be also used to help students analyze a large set of data. The statistical analysis of this data presents an opportunity for interdisciplinary studies and also satisfies some common core standards. So that's also something that's important. So some pros and cons of big data. Um, Students are going to gain experience working with real data, which should make the assignments more authentic. The skills that they develop are relevant in other subjects, as we mentioned, statistics, but also psychology, business, a lot of different fields that students could go on to study are going to deal with big data in some way. Opportunity for higher order thinking skills, depth over breadth, opportunities for collaboration with other students or even classes or subjects. Okay. Two things to look out for in terms of cons are we have to make sure that our students, depending on what kind of data about a student is being collected, that we're not um, we're not in violation of any of our district technology policies in terms of student privacy. Okay. And the last thing is just that students may be tempted to sort of overarch on their claims of what their data is telling them. Okay, if we have enough data for correlation, we don't want students to think that there's causation involved. All right, in terms of TPAC, anytime students are going to be working with big data, it's obviously going to involve technological knowledge based on what we're specifically doing with the data. It could encompass content knowledge, and if we design those activities well, we should be able to work in some pedagogical knowledge as well. So, with the right activity, we could easily hit that sweet spot that overlaps all three. But definitely, throughout an activity involving big data, we would hit on a lot of these TPAC knowledge areas. Alignment with UDL. So in terms of multiple means of engagement, by working with real data, students will have a higher degree of choice and more relevant and authentic experience. It's going to foster a collaborative environment and enable timely feedback. In terms of representation, students can decide how they want to interpret and display the data. Students will work with a variety of forms of data and data sets. In terms of multiple means of action and expression, the use of different data analysis programs promotes student choice in terms of representation of their findings. Pattern recognition can help lead students to those cross-cutting concepts that are part of our standards. And last but not least, some alignment with the SAMR model. In terms of augmentation, okay, this would be, example would be if we were to take an existing activity and just somehow work data collection software into it. So again, instead of using meter sticks and stopwatches, we can use a data collection software and students can analyze the data that way. Modification would be taking an existing activity and changing the inherent goals of that activity. So one example could be having students collect and analyze actual satellite data from NASA in order to study Newton's universal law of gravitation. And then the last one, redefinition, is sort of the overarching goal or the end goal. But at this stage, students would have a hand in developing the activity, and it would be something like a project that students design that deals with big data. Okay, so that's an overview of big data. If you guys have any other questions, feel free to reach out to me. I'm also going to hand out a handout for you guys to refer to if you have any other questions. But thanks for your time and have a good one.